Hello everyone, my name is Arsen Benga. I'm part of the American College of the Middle East in Kuwait, and today I'm pleased to share with you the findings of our recent research entitled Efficiency Measures of European Railways Considering Sustainable Mobility Objectives, a Data Envelopment Analysis Approach. This work is elaborated in collaboration with Mr. Manuel Arana Jimenez from the University of Cadiz, with Maria Jesus Delgado Rodriguez from the University Rey Juan Carlos and Sonia de Lucas Santos from Autonomous University of Madrid. In recent years, the concept of sustainable mobility has drawn and increased attention. It was first defined in a 1992 European Green Paper on the impact of transport on the environment as a strategy of enabling transportation systems that fulfill their economic and social objectives while curbing down the negative externalities on the environment and human health. 3 decades later, the United Nations adopted the 2030 Agenda for Sustainable Development that included 17 goals to transform our world into a better one. However, this agenda seems to neglect the negative externalities of the transportation sector, which, unlike the other branches of industry, has so far failed to reach the sustainability goals. At present, more than a quarter of greenhouse gas emissions and energy consumption is featured to transportation sector. In these conditions, there is an increased pressure for a major reorientation of the transport system towards more sustainable modes of transport like the railways. Even though railways are responsible for only a small fraction of total transport emissions, this sector has already taken voluntary action for being part of the solution through the commitment done between the International Union of Railways and the Community of European Railway and Infrastructure Companies. As it can be seen from the slide, there are 4 objectives that by 2050 aim 100% reduction of carbon emissions, 50% reduction of energy consumption, 100% reduction of exhaust emissions, and hopefully by 2050 the noise and the vibration will be no longer a problem. At this point, the objectives of this research are going to be stated as follows. At first, we aim to evaluate the progress of the European railway sector in different dimensions of sustainable development through frontier analysis methodologies in order to identify the best practices and to estimate the potential input-output adjustment of the non-efficient companies. Later, considering that the data envelopment analysis approach generally fails to ensure a unique ranking of the considered companies, we aim to extend it with a super efficiency measure that will distinguish between the frontier units. The data indicators used in this study are obtained from the database of the International Union of Railways and cover the period 2011-2019 for 14 major rail companies that are operating in Europe, are involved in the sustainability commitment, have consistent figures, and that provide both passenger and freight services. The sustainable mobility targets of European railways on energy efficiency, climate protection, and exhaust emissions are mapped in our model by using as inputs the energy consumption and as outputs the greenhouse gas emissions, the particulate matter, and the nitrogen oxides emissions. For more, we capture the economic dimension of the railway activity by including as outputs the passenger turnover and the freight turnover. The inefficiency model, which is given on the left-hand side panel of this slide, is going to be used in order to evaluate all the companies included in our dataset. A score equal to 0 means that the company has an inefficiency of 0, and any other score indicates a certain level of inefficiency. For all the companies that are found in the frontier, we're going to use the super efficiency model given on the right-hand side panel of this slide in order to ensure a unique ranking and to detect the best practices among them. The results of the proposed inefficiency model are presented in the following table. As expected, the number of efficient companies is relatively high, reaching up to 9 in 2014. Meanwhile, only 6 rail companies marked in green have been efficient during the considered time span. The rest of the units are following different inefficiency patterns. Excluding the final year of the sample, for the rest of the time span, the average sustainability inefficiency improved constantly from 27.7% in 2011 to 23.3% in 2018. The significant decline of their performance in 2019 can be explained with the beginning of the COVID-19 pandemic. The following figure depicts the time series evolution of the inefficiency scores during each of the periods for each of the targets, namely economic efficiency, energy efficiency, climate protection, and exhaust emissions. Excluding some minimal alternations in the energy efficiency scores, the rest of the sample is found to be fully efficient in this target. Meanwhile, the remaining three targets are far from being efficient. The following table depicts the computed improvements an inefficient unit needs to perform during 2019 in order to reach the efficiency frontier. As stated previously, the energy consumption input, which represents the energy efficiency dimension, requires the least adjustment, as generally the companies under investigation were energy efficient. The economic efficiency requires moderate improvements. Meanwhile, in the last two dimensions, climate protection and exhaust emissions, are required more improvements, as none of the considered companies is efficient in any of them. The second stage, the proposed super-efficiency model, is applied only to the companies that were found to be fully efficient in the initial model. As claimed before, a higher super-efficiency score indicates a more super-efficient company, as it represents a higher performance compared to the rest of the sample. As seen in the following table, integrating the result of both proposed models enables ranking the considered companies according to their sustainability performance, and in this way we detect the best and the worst performers among the sample. In the final slide, you can find the literature that supported our presentation. In the end, I would like to thank any one of you for being attentive during our presentation, and in the same time to thank the organizing committee for this great opportunity in presenting our work. If you have any question or discussion about the presentation, please don't hesitate to contact me or any other of the authors. Thank you very much.